Okay, so 4.8, Earth's geography and climate. So there's factors that influence the climate, and one of those first factors is the sun. The sun, the intensity of the solar radiation from the sun can vary over time. It can vary with season. We've already talked about that it can vary with latitude in the last note and or in the last set of notes, and these things can impact the climate. Insolation, as we know, is the amount of solar radiation over a specific area, and that angle of insolation can also cause seasons, which also impacts the climate. So, in higher latitudes, we tend to have cooler temps and less rain. Along the equator, we end up having higher temps and lots of rain. And we've talked about in the notes in this unit why that's the case. Okay, so Earth's orbit is another factor that can influence climate. The shape of the orbit can impact the amount of solar radiation, but only very minimally. So it's not a huge difference. The orbit of the Earth is the Earth's orbit, I mean, around the sun, is actually an ellipse. So it's not a perfect circle. And you can see that over here in this picture. And so climates can actually change based on the proximity of how close it is to the Earth. Again, it's not a major difference, but it does have some impact. All right, and then another factor is our greenhouse gases. Those heat the atmosphere since gases actually absorb heat. With this increased burning of fossil fuels that humans have caused, and we are causing deforestation, there's a lot more greenhouse gases that are entering the atmosphere, and this causes just more heat to be trapped. We're going to talk a lot about climate change throughout the course, but we'll really cover it in Unit 9. So we'll go into a lot more detail then, but that's what you need to know at this point. Okay, so looking at the next slide, we have volcanoes that are another factor that can influence climate, and very large, catastrophic, like volcanic eruptions, can actually put out a lot of ash and atmospheric gases. This cools the surface because it actually it collects in the atmosphere and it blocks out that sunlight, the solar radiation or the UV radiation that would be hitting the Earth. And then ocean currents, we've already talked about water having a large heat capacity. It can actually store heat energy on the planet. And so oceans store a lot of heat energy, and this impacts the current or the movement of the water. That actually causes a significant influence on climate. And then lastly, land masses can actually block the movement of air, specifically mountains when there's a mountain on the edge of a land mass. And this causes a difference in precipitation and temperature on either side of that mountain formation. And so we really need to make sure that we talk about that here, because this is called the rain shadow effect. That is where we have a mountain on a coastline. The prevailing winds actually push weather into the mountain. This causes rising air, cool air, or rising air, and then as that air cools, it actually condenses and forms rain. So the rain that happens on the ocean side of the landmass. And then on the other side of the landmass, because all of that condensation from the air is now gone, the other side of that landmass is very dry. And again, we call this the rain shadow effect. Great example of this in the United States is the Rocky Mountains, very close to the Pacific Ocean. So we have a lot of wet weather on this side, the ocean side of those mountains, and on the other side, it's very dry, warmer air. Okay, and this is just another picture to kind of show you that. All right, the warm, moist air from the ocean hits that windward side, I guess we call that. I was calling it ocean side. I guess the appropriate name is windward side of the mountain. It rises, it cools, it condenses, we get rain, lots of lush green vegetation. The other side of the mountain looks very arid, dry, desert-like, and we call that the leeward side of the mountain. So that's the official terminology. Okay, and so eastern trade winds blow moist air from the Atlantic across South America. This is just another example of the rain shadow effect. And so the windward side the over here, the east side of the Andes receives heavy rainfall, and then the leeward side of the Andes it gets very dry air. So that's just another example. There's actually a desert here along the coast of the Andes Mountains. So that's just another example of that. Negative 30 latitude also contributes to that lack of rain due to that high pressure, dry, descending air from the Hadley cell that would be spinning in the opposite direction of what we find here in North America. Okay, so describe the regional precipitation pattern for practice FRQ 4.8 that you would expect for the portion of Mexico and Central America that's indicated on the map. Make sure you justify your answer using information you've learned from this set of notes and from previous notes that we've done. You can always find the answers to this on OneNote. If you have any questions, make sure you're talking to me in class or check with me during Pathways, and I will see you guys next time.